Assalamualaikum and good day. My name is Izani. Force. We hear the usage of this term many times in our day-to-day life. We might not know that we are using it. Opening a door, riding a scooter, lifting an object are a few of the most common things that we perform in our daily life. And all this involve motion. But what causes motion? For example, if I take this ball, what do I need to do to give motion to the ball? That's right, I need to push, so I need to apply force to give it motion. And what need to stop the motion of the ball? Again, force. Similarly, if you consider the motion of a car, the engine applies force to move car, causing it moves, and brakes apply force to stop the car. And force will be the topic in this video. We're going to learn all about force, the differences, types of force, and effects of force. I will explain the concept, very easy for you to understand force. I'm sure you know what force is, but in physics, how we can define force? In physics, force is defined as a push or a pull. Now let me ask you, is force a scalar or vector quantity? That's right. Force is vector quantity. Remember that scalar quantity only has magnitude, only has value, but no direction. Meanwhile, vector quantity has both magnitude and value. And if you think about the force, it makes sense because when we apply force, it has magnitude and direction. For example, if I pull this toy, let's say 1 Newton force. 1 Newton force is magnitude and the direction is represented by arrow, here as the string. Force can be divided by two types, force at contact and force at distance. In force at contact, there is a real contact when force is applied. For example, when I push this ball, can't you see that the real contact between my hand and the ball? Or when I pull this toy with the string, there's a contact with my hand and the string. So force at contact, there is a real contact. But force at distance, contact is not necessary. For example, if I lift this ball and I drop it, how's the ball fall? That's right, due to the gravitational force on the ball and the gravitational force at a distance. There is no real contact here. Now is magnetic force. That's right, magnetic force is force at a distance. As you can see here, when I bring the magnet near the pin, it can attract the pin from a distance. So contact is not necessary, and just like gravitational force, magnetic force is also the force at a distance. Another example of force at a distance is electrostatic force. The force between charges. We know that like charge, they repel each other, and unlike charge, attract each other. But contact is not necessary. Now what are the effects of the force? We are going to divide it into 5 points. Let's start it with the first one. Force can set a stationary object into motion. For example, this ball is stationary, and if I apply a force, I can set it into motion. The second effect of force, it can stop a moving object. For example, this ball is in motion. I apply a force and I can stop it. The third effect of force, it can change the speed of a moving body. For example, if the ball is moving like this and I apply a force, I can change the direction of the ball. Or if you play cricket or baseball, you know what, when you hit the ball, you can change speed and direction of the ball. The fifth effect of force, it can change the dimension of a body. For example, if I squeeze this clay, I can change its shape. Or if I take the spring here and if I compress it, I can see I can change the shape of the spring. Or if I stretch it, the shape changes. Let's summarize what we have learned in this video. Force is defined as a push or pull. There are two types of force. Force at contact, which is need real contact. Force at distance, which is no real contact. The effect of force: set a stationary object into motion, stop a moving object, change speed, change direction, change dimension. I hope this video will help you to understand the concept of force. Thank you for watching this video and see you in the next video.